Here we have a SAT math question. Okay, let's go to the information. In triangle ABC, angle C is a right angle and point D is located on hypotenuse AB. A line segment DE is drawn parallel to side AC, forming a smaller triangle DBE within triangle ABC. The length of AC is 54 units and the length of segment D is 18 units. If the area of triangle ABC is 1458 square units, what is the area of triangle DBE? Okay, now first let me sketch a right triangle ABC. Just a moment, let me sketch it. So here we have the second leg. So the third leg is over here. Okay, here I have drawn the right triangle ABC. Let me mark A over here and B over here. And so here we have right angle. So here we have vertex C. According to the information, C is a right angle. So that's why I marked the vertex C at right angle over here. Okay, now we have to plot the point D on the hypotenuse AB. Actually, AB is the hypotenuse because this is a side opposite to right angle. So in any right triangle, the side which is opposite to right angle is hypotenuse. Now we have to plot the point D on hypotenuse over here. Let me plot the point D over here. Now what we have to do is we have to draw a line segment DE which is parallel to AC. Okay, let me draw a line segment DE which is parallel to AC. Let me finish. So I have drawn the line segment DE over here, and this line segment DE is parallel to AC according to the information we have in the question. And the length of it forms a smaller triangle DBE within the triangle ABC. The length of AC is 54 units and the length of the line segment D is 18 units. And now we have the other information. There is the area of triangle. Area of the triangle, the bigger triangle is 1458 square units. We have to find the area of this smaller triangle DBE. Okay, here since the line DE is parallel to AC and AC forms right angle with the horizontal line segment BC. So here also we have a right angle because the line segment DE and AC are parallel. Since we have right angle over here, so here also we must have right angle, and B is a common vertex for both the bigger triangle and smaller triangle. So by angle similarity postulate, the two triangles, the triangle ABC and triangle DBE are similar. So because here in the bigger triangle ABC we have right angle over here, in the smaller triangle DBE we have right angle over here, and B is a common angle for both the triangles. So the two angles of the bigger triangle ABC are congruent to the two angles of the smaller triangle DBE. So by angle similarity postulate, the two triangles are similar. Now let me write the vertices in order. So B is a common vertex for both the triangles. Let me write. So here I'm going to write the vertex of the bigger triangle. Here I'm going to write the vertex of the smaller triangle. And now I'm going to consider the vertex at where we have right angle in the bigger triangle, that is C. And here in the smaller triangle we have right angle at T. So here B. E. So the third vertex in the bigger triangle is A, and the third vertex in the smaller triangle is D. So these two triangles are similar. Okay, now we can consider the side AC in the bigger triangle, because for which we know the length. So AC means we have to consider the third letter and second letter. And so let's consider the letters at the same position as the smaller triangle. So D and E. So D, E. So what is the length of AC? That is 54. And what is the length of DE? That is 18. 18 goes into 18 one times and 18 goes into 54 three times. So the ratio between the lengths of the two sides AC and DE equals to 3:1. In these two similar triangles, AC and DE are corresponding sides. So the ratio between the lengths of the corresponding sides AC and DE is 3:1. Okay, so here from this ratio, I can get the ratio between the areas of the two similar triangles, triangle ABC and triangle DBE. So what is it? For that, what I have to do is I have to square this number and this number. So when I square this 3, it will be 9. When I square this 1, the 1 square is 1. So this is the ratio between the areas of two similar triangles, triangle ABC, bigger triangle, and the smaller triangle DBE. So this number 9 is connected to the area of the bigger triangle ABC, and this number 1 is connected to the area of the smaller triangle DBE. Already we know the area of the bigger triangle ABC, that is given in the question itself, that is 1458. But I do not know the area of the smaller triangle DBE. That is what I have to find. So I assume the area of smaller triangle DBE as X. Now in this proportion I have to solve for X. So for that, what we can do is we can write each ratio as a fraction. So 9 to 1 can be written as 9 over 1. And we can write this ratio as 1458 over x. Okay, now we can do cross multiplication. That is, this numerator has to be multiplied by this denominator, and this numerator has to be multiplied by this denominator. So then we get 9 times x, and when I multiply this 1458 by this one, I'm still getting 1458. So now to solve for x, I have to divide both sides by 9. So 9 will cancel out. I'm getting x equals to, when I divide this 1458 by 9, I'm getting 162. Actually, I have assumed x as the area of the smaller triangle DBE. So now I got the area of the triangle DBE, that is 162 square unit. So we find this 162 in answer choice C. So the correct answer choice for this question is C, 162 square units.